Thanks to CuriosityStream for supporting this episode. Go to curiositystream.com/space to learn more. The star mapping satellite Gaia has been scanning the sky for 5 years now, building a catalog that should reach 1 billion stars. Given all that data, it makes sense that Gaia has found some weird stuff. And in the middle of it all, astronomers have singled out over 20 stars speeding across the Milky Way toward intergalactic space. And stars don't usually do this. The galaxy has a lot of gravity to keep stuff in. But there are a few things that can slingshot a star out of a galaxy, and whatever the case, it takes some extreme gravitational interactions. Normal stars travel around the galaxy at a casual 1,000,000 kilometers an hour or so, but some of the fastest stars making their escape are moving over 3 times as fast, and many of them seem to be coming from the same place. The center of our galaxy. Sitting there, keeping everything glued together, is a supermassive black hole called Sagittarius A star, or Sag A star for short. It's surrounded by a huge, dense region of star formation. With such extreme gravity keeping all the gases nice and compact, some of those gases condense and ignite to become stars. So you get a lot of stars forming close together, and that means you end up with a lot of pairs or groups of stars orbiting each other while they also circle Sag A star. So let's take the case of a binary star system going around the black hole. If they're too close to the black hole to have a stable orbit, the stars will spiral inward toward it. And at a certain point, the black hole's gravity will overcome the gravitational bond between the two stars and pull them apart. The innermost star will be swept into a tighter orbit around the black hole, pulled away from its companion. But here's the thing, those two stars orbiting each other have a ton of energy between them. There's kinetic energy in their orbital motion and potential energy in their gravitational bond. So when half of that system disappears, the energy doesn't disappear with it, because energy in a system is always conserved. So when its partner leaves that binary star system and gets captured by the black hole, the remaining star suddenly gets all that energy, which gives it a giant kick across the galaxy. This process is an example of what's called dynamical ejection, but only about half of the galaxy's fastest moving stars are coming from the center, so they can't all be survivors of the black hole. There has to be something else going on to explain how all those other stars got moving so fast. And it looks like there is. It starts with a sun-like star in a binary system with a gigantic companion. These systems can exist anywhere in the galaxy, and one day the huge companion star explodes into a supernova. To understand what happens next, imagine a ball on a string. You're holding one end and whirling the ball around over your head. And then the string breaks. The ball sails off in a straight line, and the faster you're whirling it around, the faster it flies off. And that's exactly what happens to the smaller companion star. Before the explosion, there's a gravitational bond between the two stars that holds them together like a string. When one star bursts into a supernova, its mass gets scattered into space. That essentially breaks the string of the gravitational bond. Without any mass tying it down, the remaining star goes sailing toward interstellar space, moving as fast as it used to orbit its old companion. This is called binary ejection. And binary ejection probably accounts for most of the smaller, older stars that are on their way out of the galaxy. So that explains most of the stars that are leaving the galaxy, but it still can't explain everything. So finally, one last mechanism for slingshotting a star. This one is another type of dynamical ejection, but it doesn't happen in the center of the galaxy. Instead, it seems to happen when a star is booted out of its star cluster. That can happen sometimes because in a dense cluster, stars are getting pulled around on all sides by the gravity of their neighbors, and everything is exchanging a lot of energy. For instance, a star might swing close to a binary pair and get swept up in a chaotic 3-body orbit. It might split off with one member of the pair, or the stars might all end up as single stars. In the process, a lot of energy gets traded around, and under just the right conditions, a star can pick up enough energy to get kicked out of the cluster. Astronomers discovered an extreme example of this phenomenon in 2014 when they found a star 8 times as big as the sun, traveling about twice as fast as other stars in the galaxy. Hurling such a massive star across a galaxy at that speed takes serious energy, and astronomers think it got ejected from a really dense star cluster. This star was an outlier because of its size, but ejections like this happen on smaller scales pretty often, and they're probably behind many of the other stars speeding across the galaxy. The fact that these extreme gravitational interactions are relatively common in our galaxy suggests that there are lots of rogue stars flying through intergalactic space, booted from their home galaxies. Fortunately, Gaia and other surveys are still gathering tons of good data, so we'll probably see plenty more weird stuff soon. If you're interested in learning more about some of the most extreme gravitational interactions in our universe, you might like the CuriosityStream documentary, Knowing Without Seeing. It's all about black holes and how the more scientists learn about them, the more mysteries they open up. And if science documentaries are your thing, CuriosityStream has over 2,400 of them for you to explore, including exclusive originals. They cover a whole range of topics, including science, nature, history, technology, and others. You can get unlimited access for as little as $2.99 a month. And since you're a SciShow viewer, you can get the first month free if you sign up at curiositystream.com/space and use the promo code SPACE.